And now to continue with a hybrid connectivity, we have Chris Schonhut from Cobham. Chris?
Okay, thank you very much, George, and thank you very much for the Cyprus Shipping News for inviting us here today and giving us the opportunity to speak. We had some really insightful presentations this morning from the IT manager's perspective, and I'm going to continue on this afternoon's theory of hybrid connectivity, or the theme, sorry, of hybrid connectivity from an antenna manufacturer's perspective. We've heard from service providers and satellite operators, but from our antenna manufacturer's perspective, what are we doing to further improve the efficiency of communications and also help drive 100% uptime and reducing connectivity downtime? So just very quickly, Cobham SATCOM. And I'd like to start here just to give an overview of who we are and sort of where we've come from. We have the Sailor and Seatel brands in Maritime, Explorer and Tracker in the land side of things. And we've been involved in the maritime sector for over 70 years now, creating radio solutions in the first instance and then moving forwards to safety of life at sea solutions, maritime L-band terminals, maritime VSAT systems today. So we have really evolved as the connectivity and communications requirements of maritime have been driving forwards. And today, we're really focusing on new space and satellite constellations. And we're in a very fortunate position that we can work with all the different satellite operators, and we are working with all the different satellite operators to produce hardware that enables greater connectivity for vessels. So we've heard a lot about connectivity drivers today, and I don't want to go into too much detail here, but I think the use of the internet, as we all know, has expanded massively. If we go back to the 1990s, just 1% of the world's entire population were online and connected to the internet. Today, it's 63%, or the equivalent of 6.56 billion people. Now, similarly for ships sailing in 1992, at that point, it was just a VHF that enabled ship-to-shore communication. And then we had the adoption of the GMDSS satellite services and basic messaging. So in the early 90s, there was very limited ships communications and connectivity. But with the growth of the internet, we've also seen the growth of connectivity in the maritime sector. So what's driving some of this? And again, like I said, we've heard a lot about this today, but primarily and always the first is going to be distress and safety. Any connectivity solution fundamentally has to provide distress and safety for the maritime vessel. But we're seeing that changing as well. We're also seeing part of the regulations coming in for distress and safety, navigational aids, reporting needs to be undertaken. So that is a real driver for the maritime connectivity. Operational applications, again, we've heard a lot about these today, and just a few examples below, whether it's cargo logistics monitoring just in time, route planning and fuel optimization, or just the general administrative communication of the vessel on a daily basis, moving from a very paper-driven environment to paperless vessels. And finally, the crew welfare and entertainment on board. We all have digital habits that we all possess, and they shouldn't stop when someone goes to sea. So those digital habits are very much taken on board the vessel, and this is really driving some of the connectivity. And even to attract crew now for ship owners, operators, we're seeing that connectivity is an absolute essential. So all of this drives data on board, and the digital ecosystem, or the group of interconnected information technology resources that function as a unit on board, these ecosystems are made up of all of us here in the room: suppliers, customers, trading partners, applications, third-party data service providers, and all the respective technologies in between that are all driving the use of data. And we've seen some studies that show, on average, a ship produces 20 gigabytes of data per day on board, and 42% of that data is non-time critical. So it doesn't need to be transferred back to the shore side. It doesn't need real-time connectivity. 47% of that data can be sent daily, things such as noon reports, and just general administrative tasks, and 11% of that is actually real-time data, and a lot of that is driven by the crew connectivity. Now, the 11% is where we're seeing a lot of increase. We're also seeing IoT protocols. They're widely used, but the number of data points and the number of stakeholders interested in the IoT data from the vessel is rapidly increasing. And finally, seafarer demands, they want shoreside-like connectivity, they want to stream Netflix, they want to be able to access social media. This all adds towards the amount of data being generated on board. And throwing bandwidth at a ship with a suboptimal network or suboptimal distribution of that bandwidth, suboptimal antenna systems, configurations and applications, this will run your bandwidth inefficiently, but it's also generally a waste of money. So the whole digital ecosystem needs to be synchronized and harmonized at every single level to create that high performance. So bandwidth, yes, there's lots of bandwidth coming, but it's all about using the bandwidth in an efficient way to be able to really optimize a vessel connectivity. So what's next? What's coming? If we have a look at the chart here, it's it shows the number of satellite launches from 1965. The first commercial communications satellite in geo orbit was Intelsat Early Bird, which provided telephone, television, and telefacsimile services. And if we fast forward then to 2021, we can see nearly 2,000 satellite launches per year. And that is growing on a daily basis with the likes of Starlink, OneWeb, the LEO services launching massive amount of capacity, but also geostationary operators launching more capacity as well. So all of this increased capacity essentially means increased value, bringing new services to market, emerging technologies. We heard earlier about Viasat and Inmarsat merging. The amount of capacity that they're going to be able to offer to the market is huge. Iridium have increased their capacity with their LEO network. Telesat Lightspeed are coming to market with an LEO network and a geostationary network as well. So we're seeing across the bands, KU, KA, C, and L bands, they're all bringing new capacity to market. So it's very much going to offer and open up more services in the market. There's more competition, which, as we sort of know, will create increased value for the end customer. So we're working with all these different operators to provide the antenna systems. And a few years ago, we were talking about KU versus KA as a technology. Now, the battle of the bands, this was often referred to. I think that argument is no longer valid. They're both very well proven technologies and have their own respective uses and benefits dependent on a vessel's operating area and the market that they're operating in, the vessel requirements. So it's no longer about a KU versus KA argument. It's how all of these technologies can complement each other and create a solution that works for a specific vessel operating in a specific requirements. So it's not all about the satellite either. We're seeing that a vessel can often operate up to 60% of its time in reach of 4G services. So 22% of that time in port, 38% in coastal waters. So why not use the connectivity that's available to us on our mobile phones whilst the vessel's operating in that area? And just to give a further example of this, this is a coverage of the North Sea of 4G that's available out there today, that vessels can take advantage of. They can, when sailing in these areas, they can take advantage of the 4G area. Now, this is very specific for oil and gas, but you can see that this coverage is becoming available for maritime operations. And again, in port Wi-Fi, we see a lot more of the larger ports are now adopting a Wi-Fi service, so why not take advantage of that connectivity when it's available? So the multi-layered network approach, the new satellite constellations, LTE nearshore, Wi-Fi, what does all this mean? It means more bandwidth, more throughput, and lower latency available to maritime vessels. So how do we use multi-layered networks to approach 100% uptime? What can you do today? You can combine VSAT and cellular services, and even port Wi-Fi if you're not doing this already. So you can see that with smart management in the middle, having a satellite service, if the satellite service is no longer available for whatever reason, there is a blockage, you're in port, the crane is in front of the antenna, you can then switch over to the port Wi-Fi, or if the vessel is transiting down an estuary, they can switch over to cellular because that service is available. Each service has coverage black spots, each service may have congested links, and using one above the other to transmit and receive volumes of data often can create a huge amount of uptime for a vessel over just using one singular service. So this is what we have available today from as an antenna manufacturer with our Sailor 1000 XDR. We have the ability to use LEO, MEO, GEO satellites in one terminal. You can put Wi-Fi, you can have third-party Wi-Fi devices in there, you can have LTE devices in there as well. So really a single piece of hardware, a single cable, multiple connectivity options. And this is available, as we said, on the market today. We're also working in developing KU and KA technology. So being able to switch between different satellite services. And again, this particular antenna system is available and it will electronically switch between KU and KA band. So you can take advantage of KA band satellite services when in coverage. For example, use high capacity newer satellite services when that's available. And when that service is no longer available, you switch over to your KU service. So we're seeing multi-layer communications already available. And this is a very large antenna, but again, this is a tri-band antenna that can use KU, KA, C-band, and also LEO, MEO, and GEO. So again, a single piece of hardware that is offering multiple connectivity options for a vessel. So just finally, why choose hybrid? You can choose the right communications bearer based on the location of the vessel, the data type. Is it critical data that needs to be transferred? Is it non-critical data that you're transferring? And subsequently, you can get the lowest cost, the right amount of bandwidth, the availability, and the lower latency for those applications that need it. You can also reserve specific networks for critical applications or use high capacity in regions when it's available. And of course, finally, you've got full communications redundancy when using these hybrid style solutions. So that's pretty much it from me. just as a very quick update on the antenna systems that are being developed, what's available today on the market, and all these new satellite constellations, these new networks that are coming to market, the antenna systems today are ready to take advantage of those services. Thank you.
Thank you. Hybrid connectivity is the buzzword of today. Some interesting thoughts and ideas here.